Hi, and welcome to INVISQUE, the Interactive Visual Search and Query Environment, a project funded by GIS's Rapid Innovation Program and developed here at the Interaction Design Center, Middlesex University. INVISQUE is a prototype user interface that uses a non-conventional interactive visualization approach for information search and retrieval of electronic journals and books contained in modern library holdings. It represents what we hope will be the next generation of user interfaces for future library electronic resource discovery systems. In a very short video clip, we hope to just give you an overview, a sense of the non-conventional INVISQUE design. A design where we attempt to move away from the traditional list of lists approach to a design based on an interactive visualization approach that emphasizes representing relationships within the data. We will discuss the interactive visualization features of INVISQUE in more detail in part 2 of our presentation. The interactive visualization approach we adopted is based on a number of information design principles and concepts. These information design principles include the focus and context principle, the proximity compatibility principle, the Gestalt principles of form perception, the principle of visual affordances, ecological interface design, and the representation of functional relationships. These principles are implemented in our design through the use of visualization techniques such as animation, transparency, information layering, spatial layout, and pattern creation techniques that emphasize the representation of relationships amongst the data. In this way, we intend that INVISQUE will help the user discover expected and unexpected relationships. By orchestrating the interaction in our design, INVISQUE enables rapid and continuous iterative querying and searching while keeping visible the context of the search. And in this way, we hope to be able to minimize problems such as wolfing, the problem of what was I looking for. We will now proceed to part 2 of the presentation to take a closer look at INVISQUE. Hi, and welcome to INVISQUE. In this part of the presentation, we will describe in some detail the key interactive visualization features of the user interface to a library electronic resource discovery system. This is the opening screen. It comprises a simple single search field in which you would type your search terms. In addition, it also has some advanced search options that would accommodate more complex combinatorial searches as required. In addition, this opening screen also presents some handy shortcuts, such as popular keywords based on previous searches and themes, which are collections of, say, articles organized by topics. Well, let's start our search by simply typing in the keyword technology in the search field and hit the click button, search button. It is important to notice that INVISQUE search results appear on the screen in a large windowless display, borderless display, where its size is limited primarily by hardware memory constraints. So we can move this around and really leave our search anywhere, our cluster anywhere we like to be able to. Now, INVISQUE presents a visualization of the articles that correspond to the search term. Each article is presented by an index card, which include the essential bibliographic information, such as title, author, keywords, name of journal and volumes, and a number of citations at the top of each index card. In this case, we have some fictitious citation numbers. Each information is also linkable to allow the user an easy access to other details. The index cards are presented in a cluster organized by publications, by publication year along the x-axis. So most recent, older articles, and the number of citations along the y-axis. Such information is usually not available together, and the current electronic discovery systems often reside in different databases, which require a user to access separately and then combine the information for himself. In this way, INVISQUE combines two dimensions that may be important to a researcher and can transform the task from a more effortful cognitive task to a relatively easier visual search and comparison task. For example, the index cards that are higher up on the y-axis represents the more frequently cited articles, and those along on the x-axis are those that are published more recently. So this visualization helps answer the question, which are the more recent and most frequently cited papers, very easily. Each set of index cards is associated with a slider at the top. The purpose of the slider is to change the weightings of the displayed dimensions. By tightening up the weightings associated with each filter for that dimension or changing the window values, the slider can increase or decrease the number of index cards dynamically, like so. The user may be curious to see what other articles would be found by searching with another possibly related search term. And by clicking anywhere on the white space, like so, the user activates a search function and can key in a new search term. In this case, let's type in management. The system presents the second cluster of index cards, representing articles found by the second search term. The new cluster is presented in the primary layer, appearing in the foreground, whilst the older cluster appears to recede backwards into the background, what we call the secondary layer. By using techniques to fade and slight size reductions, we are applying the Gestalt law of figure and ground, drawing attention to the objects that appear closer in the foreground, while still showing previous searches faded in the background. The user can also click on a keyword or alter the filter options to see what articles are related by citation, title, journal, conference, and perhaps even themes. Well, rather than using lines to relate the same or related keywords by authors, the system would just highlight the keywords, for example. It is almost immediately clear to see where all of the related articles or potentially related articles are located. One aspect of query modification is filtering and merging of results. In INVISQUE, the user can drag and drop multiple results to invoke various Boolean operations. In the example we'll show you, it's just simple merging of two different sets of documents. We drag management and drop it on top of technology, and we have selection that combines the two sets. Now, such actions does not require any knowledge of any particular Boolean syntax, and we are still working on developing such a set of combinations of actions. The highlighting combined with the figure and ground effects helps direct the user's attention to the new relationships that they might want represented. This also allows the user to quickly identify index cards that share a common attribute and construct and modify queries in other non-complex, natural ways which require no knowledge of the specific search syntax. In INVISQUE, there is also a visual interaction for the drill down function from the index card. For example, we may want to be able to read the article that has just been highlighted. As we do that, it drills down to the actual article itself and allows you to show articles that are of related to it, reading the article, and then you may want to be able to visit the table of contents And as we click on the table of contents, it brings up the table of contents of the article. It allows you to see what other articles have been published, perhaps in a special issue. In this way, we support the functions of serendipity, something that sort of allows us to find things by chance by browsing through the data set. Now, the other function that we can also have is what we have implemented is also called the wizard functions. Oops. Now, these circles are arbitrary designs at the moment. You can have them placed anywhere. You can have circles, you can have shades, you can have anything else. But the idea behind these these circles are to allow you a drag and drop functionality for moving articles around. For example, if these are the articles that you may not be interested in, you can simply drag it into a not particularly interested area, and it will delete them. At the same time, it will also inform the system to not bother or lower the weightings for the search criteria for these articles. If you are interested in a particular article, you could save them here. And it will just save the articles for you and stick them into a repository. And if you're not sure that you may want them, you may put them in another space. That allows you to simply collate them later or retrieve them at some point in time. Now, if you wanted to then, let's say, assign the saved articles to a particular theme, we can add these articles that has been saved here to a new theme. We will call this my special theme. And we can save that theme. It could be another title or whatever. And you'll find that these themes are then available, and you can then subsequently retrieve them quite readily. Right. In addition to this, in our other work that we found with user behavior and resource discovery systems, sometimes users come to a blank wall as far as new ideas or search terms to use. And they often, as a result of that, branch out from the electronic resource discovery system and look for terms on the internet. So from INVISQUE, we can also directly query external sources. For example, we could, using the same terms, access technology, for example, on Google search. And look for other terms that exist. This is live at the moment, and maybe you could even want to bother with look for Twitter, looking for entries on Twitter, and here is a whole bunch of things here as well, which could prompt new ideas to allow the user to then look for additional search terms and helping them continue in the search. But it doesn't have to be purely Google or Twitter. It can be any other kind of application that you might need. What we're showing here is a mechanism whereby you could access other internet-based or non-internet-based functionality. Okay, so this is a very brief example of what INVISQUE is about. And I hope through this short demonstration, I've been able to explain to you what the future might hold for user interface designs to electronic resource discovery systems, and potentially to other search and retrieval systems for accessing large data sets. Thank you very much.